Here we're interested in calculating change in chemical potential for a single component as we increase the pressure at constant temperature. Well, if we look at the differential change in chemical potential related to pressure change and temperature change, since we're doing this constant temperature, the second term is gone. Well, what we're going to do is calculate a finite change, which means we'd integrate, but what we're going to do is use an average value for the volume because the volume doesn't change significantly for a liquid in this pressure range. And so if I look up in this steam table as the volume, this times 10 to the minus 3 cubic meters per kilogram. Then the pressure change, final value 10 megapascals, the initial value 0.1, so that's megapascals. So change in chemical potential, if I multiply this out, 9.98 times 10 to the minus 3 cubic meters, megapascals, kilogram. Now, more reasonable units would be to convert it to kilojoules. So 1 kilojoule is 10 to the minus 3 cubic meters, megapascals. And this becomes 9.98 kilojoules per kilogram, which in reality for significant figures is 10 kilojoules per kilogram. So that's a change in chemical potential. It increases as we increase the pressure at constant temperature.